Assignment. Okay, we're going to walk through a few things in chapter 7 and chapter 8. And I want you to open up idle, if you wouldn't mind. Let's create a new file. And let's save it as something like today, October 23rd in class. That way we don't mess them up. Alright, now I got to somehow get them on the screen. Okay. Now the code I want to look at first is this method right here called define number. Is that the one I want? Actually, let's do this one first. Counting digits. Okay? This is in the textbook. I'm going to put it in here. Let's talk about this for a second. Okay, so first of all, this is a function. How do I know it's a function? Anybody? Because the def. We're defining something. Obviously, we're defining a function. So what's the name of it? Num digits. And while I'm here, someone sent me an email this morning. It was not one of you. It was a different class. And the student said that she keeps hearing that there's many ways to write programs, but every time she tries, she always ends up with the same thing. So how is it that there's more than one way to program? How is it that there's more than one way to write a program? My example was, imagine driving through Oklahoma City, downtown. Is there more than one way to get to Oklahoma City? Yes. And it's the same way with writing a program. A lot of you guys in here take my actual code, but you can change it. I mean, what I gave you is just a sample, okay? You can always take. Now again, we're going to look at these these methods that they made in the book, but that's not the only way to do things. There's actually a lot shorter way to do things, a lot different ways to do things. Okay? So we have a method here called num digits, and what's that n in parentheses? What's that called? Parameter, or also an argument. Depending on which way you read it, it's either one. Now, how do I call this function? Does anybody know? So if I call num digits, and spell it correctly, and first of all, what is n? Is n a string or is it a number? What is it? You sure it's an int?
It's a float.
I heard an int and a float. Well, let's try. Let's put in, say, what number should I put in my parentheses here? We'll do 7 first. Now, when I run this, what's going to happen? What's it going to do?
Should return a 1.
What will print on my screen when I run this? Anybody?
Nothing.
Absolutely nothing. Because it's returning something, but we're not doing anything with what we're returning. Okay? We have a return statement here, and we haven't looked at what the thing's doing yet. But we have a return statement, so this function's returning a value. We're just not doing anything with it. So how could I do something with it?
Print.
Yeah, I could print. So I could print. So now at least it'll print out what gets returned.
Nothing because you raised the int.
Smarty, Mr. Harold. Okay, I got a 1. So is that telling me that 7 is equal to 1?
No.
What does that mean?
Number of digits.
Yeah, hence the number of digits. So if I did 25, what should I get?
2.
Should. Okay, so is it working as advertised?
I hope so.
I hope so. So if I put another 5, I should get a 3. Let's look at what this one does. Okay. So we received the 255 right here. So if we were to trace this program, don't write this. I'm just going to make my trace here. So n starts off at 255, okay? So we receive n is 255. Then while count is 0. Actually, let me put these in a little chart here. Let's do this. Okay, n n is 255. Ugh. Okay, I can't do it inside here. Let me get out of here. Let me go in Notepad. Yeah, the editor doesn't like that. So I'm going to trace this program. So n and count. N has 255 in it. Count has what? 0? Everybody follow me so far? Why? I mean, is it important to trace our program sometimes?
Yes.
Yes. Very important because, you know, they might work right, but they might not work right. You know, me and Roy were running wiring this weekend, and we had to find out where the wiring went from my main circuit breaker panel, which, believe it or not, I'm not an electrician. But we had to open up the main circuit breaker panel, but we had to trace a wire to find out where it actually went. Okay? The same thing in our programs. We want to trace what they actually do because we might write code and our logic could be off. Have you ever done something wrong? Yeah, we all have in our lives. So tracing a program helps us find those logic errors. And I always tell people, you know, when you run a program, run it with more than one value. Because if you run it, you know, we used to have a guy by the name of Grant Cadis here. Grant was amazing. Grant wrote a lot of code for us. And it would always work like one time. With this one value he would give me. But if you put in a different value, it would crash and do all kinds of bizarre stuff. So we always made fun of him that, yeah, Grant's programs are great one time. So the point is we need to trace this. So, okay, so we received 225 at this point. So while n is not equal to 0. So is n equal to 0 at this point? No. Okay. So the next line says count is equal to count plus 1. So what happens to count? Count becomes 1. Then n equals n. What the heck is that?
Divided by 10.
Divided by 10. But why has it got two divided symbols? Integer division is what it is. So 255 becomes what? N becomes 255 divided by 10, which would be 25, not 0.5. It would just be 25. If it was a single divided, it would have been 25.5. But since it's a 2, it's an integer division, which means it just returns an integer. So we get 25. So, and then what happens at this point? So is n greater than 0? While n is not equal to 0. Is n not equal to 0 still? Correct. So we're back up at this while statement right here now, because you know we got this one done. We come back up here. While n is not equal to 0. N is not equal to 0. So then count becomes what?
2.
Count becomes 2. Then what happens to n?
2.
N gets divided by 10 again, so n becomes 2. Okay, while n is not equal to 0. Is n equal to 0? No. So what happens to count?
3.
Count becomes 3. Now what happens?
0.
2 divided by 10 is 0. While n is not equal to 0, it now is equal to 0. So we get out of our loop and return count. What's count? 3. Easy enough to do. Everybody see that? Are there easy ways to do it? Yes. But this one works just fine. Let's try it with a different value to make sure we're doing it all right. I want to put 14 in here. It's always a good idea to test it with multiple values. All right, so now we're passing 14. So n gets what? 14? What does count get?
1.
0, because we start at 0. Okay, while n is not equal to 0, is n equal to 0? No. So what happens to count? Count gets, what did I do? Hit the wrong button. Count becomes 1. What happens to n? 1. Okay, so n becomes 1. Is n equal to 0? No. Okay, count becomes what?
2.
2. N equals n divided by 10. What do we get? 0. While n is not equal to 0, it is equal to 0. So now we eject out of our loop and return a 2. Easy enough to see? What?
Each time I run it, I get 1.
You copied their code indirectly?
Yeah.
Well, you didn't. That's all I can say. You didn't. Let me see what you got going over here.
I think I figured it out.
You're missing the colon or something, or?
No, the return
Yeah,
statement
the
was.
return.
Oh, you had it over too far?
Yeah.
Yeah, because if you have this over too far, it's going to return the first one, which will be 1. Every time it'll be 1. 1. Let's test it with another digit. 1.
That's the problem I was having.
Okay, give it a couple extra digits. 1. Okay. All right, so that works. What if I wanted to know exactly what the value of n is each time? Could I check that?
Yeah.
Print n and put this back where it belongs. So let's see what 14 does. So it's going to print out 1, 0, 2. Okay? So n started at 1 first, then it started 0 the second time, then it returned to 2. Easy enough? Is everybody okay on tracing these things? Everybody see how that works? Let's walk through the second one. Number 0 and 5 digits. Okay, I'm going to replace mine up here. Num 0 and 5. Wow, could they make that any longer? All right, let's see if we can figure out what this without cheating, without running this. Okay? So it receives an integer. So if we were going to walk through this thing, don't cheat and run it. I'm assuming it's looking for 0s and 5s. I'm just assuming that. So I'm going to change my number to 250. Okay? I'm just doing that. So n starts off at 250. Y'all with me?
Yes.
What's count start off at? 0. Is n greater than 0 at this point?
Yes.
Okay, good. Oh, we've got a new variable called digit, so I'm going to make another variable, digit. Digit equals n percent 10. What in the heck is that?
Remainder.
Remainder, modulus. So what is n, or 250 mod 10?
What would be left over? Oh,
So
for
what's-
that, it would be
So what is 250? How many times is 10 going to 250?
25.
25, so
What's the remainder?
0.
So the remainder is 0. You get it? I mean, is that correct? Okay, we're not running. We're just walking through this thing. If the digit is equal to a 0 or digit is equal to a 5,
add.
so do we have one or the other?
Yes.
Okay, so what happens to count? Count becomes 1. Then n is equal to n integer division 10. So what happens to 250? 25. Okay? So we're right here. We just became 25. So now we go back up to, where do we go back up to? Do we go to here? No, we go to the while loop. So is 25 greater than 0? Okay, it is. So what happens to digit? Digit equals n mod 10. So what do we get now?
Digit becomes 1.
5, exactly. 10 goes into 25 twice. Remainder 5. Okay? Everybody see that? And if you're not sure, there's always this handy dandy calculator right here. If you did 25 mod 10, you get a 5. Okay? Alright, so digit becomes 5. So if digit is equal to 0 or digit is equal to 5, which in this case it is, what happens to count? Count becomes 2. What happens to n? Becomes 2. Okay, so everybody see that? We're right here. N is now 2. Is it still greater than 0? Yes. So what's digit become? How many times does 10 go into 2? 0. What's the remainder?
2.
2. Very good. So many times when you have low numbers like that, people do the opposite. I've even done it myself. Instead of how many times does 10 go into 2, your brain just says how many times 2 go into 10. It's not. It's the other way around. whenever you see modulus like this, the number on the right goes into the front. Kind of like, you know, when you're doing that old, here, I'm going to show you some awesome paint skills here. So, you remember this thing here? That thing we did in school?
Yeah.
So the 10 goes out here, and N, whatever N is underneath there.
That's what you do on the personal finance test.
Okay? So you got to remember, whenever you see a percentage 10 or percentage everything, this value here goes into the front. And if you do it any other way, I mean, so many times, if you see a low number like, 2 mod 10, you're like, oh, that's 5. No, it's 0. I mean, it's 2. Shit, I did it again. It's 2. See, I do it all the time. And I know better. Okay, so we know digits now equal to 2, because we just did that. If digit is equal to 0 or 5, it's not. So what happens to count? Stays the same. N is, so what happens next? N becomes, it's no longer greater than 0, so what do we return? Which is 2. 2. We're still at 2, aren't we? Now let's test it. We haven't ran it yet. Let's see what we get. Hopefully I'm right. I hate being wrong. Yes. Everybody follow that?
Yep.
Simple to do. Simple to walk through. You know, it's not critical you do this step here, but so many times we've written a program, it's like, it's not right. Or I'll write something, literally, I'm writing all these scripts for cryptography, and I make hundreds of them randomly. But I like to go through and just check some of them, because when I assign them to all the students, it's a good idea if they're actually done correctly. And sometimes my random number generator will be off or something, so I have to figure out what the heck I did wrong. Okay, so far so good, everybody with me? All right, let's move on. All right, let me make this bigger. Okay. You know what the assignment operators are. We're not going to go through those. We're not going to worry about that. Tables.
So is that just, for that second one, is it just telling you how many zeros?
How many zeros and 5s? Yes. Yeah, not how many digits, how many zeros and 5s. So, you know, that's actually a very good question. Let's modify this. I want to know how many 3s we have.
It's digit.
How about we say num3? Number 3's let's see, num3 digits. So let's modify this so it works for 3s. Now I'm going to pass it 231. What should I get when we do this correctly? 1. I should get 1. How are we going to do this?
If digit equals 3.
Dude, you know all the answers. So can I get rid of this?
Yes.
By the way, this is going to be important in your next assignment. Not exactly, but somewhat.
Yeah, that works.
Does that work now? Is that all we had to do?
Yeah.
Sure.
Seriously?
Yeah. That's it.
All right, you know what? I don't believe you. Yeah. Nope, wrong number. Yeah, it should get a 3 now.
Interfere with it?
What now?
No, never mind.
It shouldn't.
I got a zero. See, what you do?
Mine worked.
3, 1, 3.
You did change this right here, didn't you?
Oh.
What'd you change? What'd you do wrong?
They were still 250.
Oh. Yeah, you kind of need to put a 3 in it if you're checking for 3s. I'm just saying. So I want one that will check for... Don't know if this will work. I want to check for 12s. Is that what you're thinking?
This may be hard though, because it's 2 digits rather than 1, so then the divide.
I don't know. Let's try it.
Integer divide wouldn't work, right? Would you have to divide
Let's
by
do the
100?
same thing. Let's just do this. I don't know what it's going to
Would you
do.
change the integer divide to 100 to make that work or not?
Well, let's just see what it does first of all. We're going to fix it. Oh, wait a minute. I got to call it the right thing first.
two numbers.
Can we do it? First of all, let's see where our error is coming in. Obviously, receiving 12, no problem. Count as 0. So this is true, obviously. So 12 mod 10 is what? I'm going to pretend to do this with one hand. See if it can be done. 12 mod 10.
Remainder 2.
Ooh, that's going to be tough. So obviously our mod's not going to work. So what if we do, like Natalie said, let's bring it up to 100.
I think mine worked.
So we got a 12 in there now. Let's get rid of the 12. Okay, it's working. So now what if I do 1, 2, 1, 2?
It works.
Whoa.
But I changed, that's weird, because mine's working too, because I have my in with the the integer divide to
Yeah.
at 100. Missed doing the
Well, because what you're doing is you're cutting it down by 2 numbers each time.
yeah.
But what if the number was, try 3, 1, 2? I bet it doesn't catch them. With yours.
What was it? 3, 1, 2, 1, 2?
Yeah, I bet it won't catch them because it's going to do 31 then
No, I
21.
did it.
It still got them. Wow. Digit is 12, so it's checking.
So when it does that, it's pretty much just that, like, looking at it from a point of view that's like, it says 3, 12, 12, so it's just looking at 12.
It's just looking at the 12s.
Okay.
Yeah, so it works. So, no, you don't have to do that on your homework.
Ooh, this didn't work.
All right, so it's not that hard to change these around. Let's do this next one they
Mine
got
didn't
here.
work when I did a longer number.
It didn't?
It did 3 when there was 5.
Oh.
Okay,
Well, we're going to
but
skip
I
that.
got rid of it from the 100 and it worked when I did
Now I'm
that.
putting this up here. So I'm going to tell you what this is going to do without cheating and running it.
It's gonna print off 1 times, it's gonna do a times table, so it's gonna be 1 and then 2 and then 2 and then 4 and then 3 and then 6.
Gonna print 13.
Should print off a 1,
5.
and then 2 times 1. 1, then it's going to be a tab,
It's gonna
that
go
slash
to
T.
13 and then multiplied by 2 is the second column. Oh no, it's, what do you call it?
It's that.
Powers, right?
Yeah, it's exponents.
Exponents, that's the word.
Exponents. Because we got 2.
And that's what the little stars.
But the point I think they're trying to make here is this part right here. The slash T. What's slash T mean, anybody?
Tab.
Tab. What's this slash? Anybody know what that is? It's called an escape character. It basically tells the computer, hey, if you see a slash that's not part of a division or mathematical calculation, something special is coming up. So what happens if I put an N there?
New
Anyone know? Oh, too quick. Anybody but Natalie? New line. So you can use it to put in carriage returns. So maybe you want to print something, and imagine hitting the enter key and print something. I mean, it looks stupid, but so yeah. So yeah. What if I want to have 2 tabs?
Do it twice.
Let's do it twice.
Is there a way in Python to do new line not inside of the thing? Because like in Java you do print line.
Yeah, print element and then.
Yeah.
You just do print and another print and print it. So it's just a new line.
Oh, I guess, yeah.
Yep. Oh, duh, it even says it right there. Slash sends new line. Well, that sucks. It's right there on the darn screen. They cheated. Let's see. An escape character can appear anywhere within a string. And there's our table we generated. Pretty easy there. Ooh, let's look at our 2-dimensional table. Let's see what this guy does. 2, 4, 6, 8, 10. Well, that wasn't very two-dimensional, was it? All right, let's see what they're actually doing here. From range 1 to 7, let's start with the sequence of 1s. Loop executes, changes to 6. The extra end equals argument in the print function suppresses the new line and uses 3 spaces after the loop completes. So that's something new. So the end equals, see if we got rid of the end, it would do a new line. This way, there I just wanted 2 spaces instead of 3. I did not know that. It's something new to me. And basically does not tell it to print the new line. But if I was to take that out, watch. Now we should get new lines.
So it adds that to the end of each print?
It prints it, but it basically says this is not the end. So you'd think it'd say not end, but the end equals arguments print function suppresses the new line and uses spaces instead. Okay. All right. So now we need to. Is everybody kind of following along? We're not really doing nothing too special here. I like some of their little code they put in here. Let's see what the next one does. All right, so how do I run this one?
You have to call.
Print multiples of what? 7?
Another print.
So I should now get 7 and then 14 and then 21 and so on and so forth. Except it's only going to print 7.
You don't have to print it out, do you? Because the whole function prints them out. That's the point of
Oh,
it.
good point. And I actually is because I called it wrong.
Yeah.
Something still looks wrong.
No, that's right.
Oh, it goes up 7 times. That's pretty handy. Y'all like that? All right, now we go with 3s and 4s. We did it with 7s. Nice. Okay.
Oh, I like the tape.
Okay, let's print that one. So if we do this one after this, oh, that's going to be awesome. Very nice. But we need to make it look better. Okay, how come mine doesn't look like theirs? Someone's got to help me fix it.
It's not lined up.
It's not lined up. How do we fix that? Come on, someone's got to know.
Do we have to do the end like wait?
I think Nathan kind of said something. What did you say, Nathan?
Put an extra space in the end.
I don't want to do that. Anybody else?
Is there a special like spacing character like T?
There you go. /T. Look at that. I tell you, so many people, even like when using Word, they space over instead of tabbing over. I hate using spaces as a space, basically. Because now with our true type fonts, they're not right. So what happens if I print all the way up to 25? So the tab even made the ones that are 3 wide still aligned. Everybody got that to work?
Could you use that to like input into a spreadsheet program?
You could. You actually could because this is called it's called. Here, actually, let me do this. I'm going to do what Ruben's doing back there, put in some huge number. Okay, maybe that's too big.
Oh, yes.
Is that what you put in, Ruben?
I put in 250.
Now, if you want to put this into like a CSV, you just got to select it all. And since it actually has tabs in it, I'll show you what it does. You can actually copy this, go right into Excel, and paste, boom. Isn't that nice? I know that 'cause that's what I do with all my stuff. I make CSV files. Then you can save this as a CSV or actually Excel. Because the tab makes it put it into another cell. Isn't that nice? All right. Let's see what happens if I just put the spaces they had and put, we'll just do 10 so it goes quicker. First of all, it's not lined up with a hill of beans. Now I'm going to go into Excel. You'll notice they're all in one cell because it needs the /T to put it in different cells. So word to the wise, don't ever use spaces, always use tabs. Alright, let's see. We already talked about little variables. We already talked about break. I think we're pretty much done with 7, aren't we? There's something else I want to show you if I can find it. We've already done random stuff a whole bunch. Actually, I want to try something here real quick. I want to go into our code. I want to make a new method. It's going to be called num of digits, kind of like what they did, but I want to do it differently. You know how we did num digits up the top, and they basically were dividing by 10 and all that? Remember that? How can I num digits, let's say 25. I want to write this differently. Okay. I'm just writing. Does anyone know what it's called when you actually write a method like this that's not really complete? There's a name for it. Anybody? It's called a method stub or a function stub. We're writing it so it's got the right number of arguments, it's got the right return function, but really doesn't do anything at this point. We're doing it just to make sure our calls are all correct. Now we're just going to go back and fix this part. What's another way I can check how many digits are in that number? Anybody? With potentially one line of code.
Isn't there a string method that like checks the characters in the string?
So, there is a string method for length.
So you convert it to string.
Convert it to string. So what if we did num equals str n? So now num is going to be a string, correct? Let's see what we get now. What should it return at this point?
It'll return 25, but it should be a string.
Should return 25 as a string. Now how do we check the length of something?
LEN.
I think it's len. Won't that do it? Do. I lost my mouse. There, mouse. Let's test this. So now we should get a 4. I know some of you are like, slow down. And this actually pertains to your next homework. But what if I didn't want to put this here? What if I didn't want to have any lines here?
Yeah, yeah. You could just take, I wonder if I can do
Return string.
Wow.
Will that work?
that. Oh, I almost broke it.
Works like a champ.
Okay, there.
So what do you think? Is that easier than that the code they had? Let's go up and look at the code they had again. I know some of you are saying, don't get it off the screen yet. Theirs was up here at the top, wasn't it? Where was it at? Number of num digits. So whose code's better?
It's different.
Neither one's better. They're the same.
They both do the same thing. But mine's obviously better. Now, here's one thing that's might amaze you. What do you think happens when this is actually run? Do you all know how compilers work and how interpreters work and all those? It reads what we're telling it. Then it converts it in basically to assembly or object code and then runs it. So really, they probably both end up being the same darn code anyway, or code that's very similar. So we teach a reverse engineering class where we actually take programs and decompile them back down to assembly language so we can actually see the actual code that's produced. And it's amazing. Sometimes you get code like on the left and it ends up being code like on the right. Because the compiler is like, hey, all you're checking is the length of a string, and it literally just does something like that. It's kind of cool. I just think this code is so much better. But if we're doing that, then why didn't we just take this little bit of code here and put it right here? Because it's easier to remember this name, num digits, than len and string and all that other stuff. Okay?
You can use it more times, though.
That's right. You can use it as much as you want. You can actually put this in your own class. Way back when I used to actually write software for a living, I used to make the Ken class. It was called Ken Utils. And everything I did a lot, like, y'all know what padding is? So when you take like something, you pad it to the left or pad it to the right to make it centered or left justified and all that. Well, that wasn't available in the language, so I wrote my own. But that was part of my Ken Utils. So I could always call Ken Utils pad L, or Ken Utils pad R, or Ken Utils pad C for center.
That's what
So,
the kid did in my AP class.
Yep.
And Miss Westerno gets so mad because she wouldn't know what he was doing in his programs.
oh, he would call his own little
He would, yeah,
classes?
he wrote his own class, and so the teacher should get so mad because she had no idea what he was doing, and
Yeah.
he'd be like, "Well, it's just simple. It's
Yeah, because if you write it once, that's the whole point of object-oriented programming is write it one time and use it forever. So in Java, I know you know Java, Java prior to version 6 did not actually have the scanner class built in. You actually had to write your own scanner class. I know, it was like nightmare. So what we would do is you write our own scanner class and always include that. You're always including your own scanner class to provide the functionality. Then Java finally put it in. So it's... All right, let's see. Okay. We know about that. We did that one already. Let's do this here. Let's see what this code actually does. All right. I don't know what this does. I'm going to run it. See what it does. 12, 16, 24, and 30. But what did it actually do? So for 12, 16, why did it skip 17?
It's not divisible because it says if the number is divisible by 2 and it equals 1, then don't print.
If it's odd, yeah. If it's odd,
So if it's odd, it does print or doesn't print? So do y'all see that?
because 29
Right. So this here is basically checking, is doing mod 2. So if it's equal to 1, keep going. Okay? In other words, continue. It's an if statement that you don't really want to do anything. You don't want to print. You don't want to do a calculation. So it's saying if it's an odd number, so if I was to add like, let's add 6, 7, 9, and 11. So it should only print the 6 out of all those, correct? Let's try it. Yeah, that's all it printed. So this function only prints out the even numbers. So that the control flow statement causes the program to immediately skip the body of the loop for the current iteration. But the loop still carries on running for the remaining operation. It just kind of skips it. So it skips this whole print thing. Let's see if there's something else I want to do in there. We've already done that one. I don't want to do high-low at this point. Ooh, we haven't done paired data. They don't give us the whole code. They're going to start getting into dictionaries here in a minute, which we haven't done yet. List of Python, we're going to go ahead and making a pair of things and simple. Let's just do those. Let's see what it does. Paris Hilton, year born is 81. Very overpriced celebrity. So if I run that,
She's older than
it does nothing. Okay? We can also put pairs. Actually, what? Let's print out. Let's print out year born, see what we get.
I guess that's not that old, but she's
You see, we actually get a paired data. We'll learn. So we're saying that this one variable actually contains multiple items. It's like an object has two different data parts to it. Okay. Now we can also make a list of those. So in their example here, we could have celebrities. I'm going to put the celebrities in there. I know you guys are like, why do you keep changing it so fast? I'm just copying right out of the page, by the way. I think some of you are giving up copying me. So, do you think I could print out? So, what can we do with lists? Anybody? Can we print out specific elements?
Yes.
Okay, so how do I print out Jack Nicholson?
Print celebs
One?
Correct.
Yep. Now, there's a way I want to print out just the name Jack Nicholson. I don't remember how to do it. Hold on, I gotta find it. That'll tell us how long it is. Come on, there's a way to do it. Okay, from num years and celebrities, I can print. Hold on, there's a way to do it. I want to print out just the name. Yeah, but that's only for that. So that's printing out. We got to get this one to work. It's been a while since I've done this one. I want to get the first element of that. Can I do 0? Not sure if I can or not. Yes, I can. That does it. Okay. What I told it was print out celebrity 1, which was the second element. So celebrity 1 includes Jack Nicholson. But from that one, I told it to print out the first element. So if I wanted the 1, what'll that get me? If I do 1, 1.
Name, oh, just the year now. Is it not, oh no, is it the year and the name?
I'm going to get 1937. Because it's going to print out celebrity 1, which is this guy. But this is actually a list inside of a list. So this 1 is going to print out the second element in this list. So it's going to print, it should print 1937. Now what if I wanted to also include their let's print out their sex. Male. Male. Not really sure. So what am I going to get this time?
M.
I'm going to get an M, but whose M is it?
Jack.
So now if I go 2, what am I going to get?
Question mark.
Question mark? Because we don't know what just to be written.
So I got something, can you make it print out Jack Nicholson and male?
I would have to print out 0 and a 1. That'll give me Jack Nicholson. Then I would have to print out, I'd have to take this again.
So that's how you have to do it. You
Yep.
couldn't do, in the second part, you couldn't do 0:2.
Actually, you know what? That might work, actually. It might, but I think we're going to have to change one thing. That actually might do it. I never thought about that. Yeah? No, now this is giving us the range. So, because it goes to the n minus 1. But if we did 0,
-1.
comma 2 might do it.
Yeah, I tried that.
No, darn it. It's not a slice. How can we do that? Because we did 0.
Try changing the 2, or do colon -1.
No, still didn't give us it.
Why is it not going to the M?
I bet if we did just that,
Is he that
Well, if you did, took away the colon thing, then what it should give you M, right?
yeah, it gives us the end. But we want the 0 as well.
Should have put it in brackets, or not brackets, but,
That?
no, other thing.
Oh, hold on, what's that one give us? No, it's trying to do math. You can't put it in this because it's no longer an index value. I don't know how to do that one. I think you would have to do 2 separate items like I did. I don't know an easy way to do that. Unless you made a slice out of it. That's too much work at this point.
Okay. Something like that. I thought maybe it would be simple.
No, I can't think of offhand how to do that.
Because if you could make it that simple, then our homework would be super easy.
Yes, well. All right. We don't care about square roots at this point. That's all of chapter 7. We really don't have time to do that. Do this for me. So for today, what you're going to print out is not that. Oh, I got too many parentheses going here. Okay. Just give me a snapshot of your code saying you did this. I want to know you did something. Just like just this picture right here is perfect. I have to go make it so you can put it somewhere. Because there's nowhere to put it right now, is there?
No, there
There's fixing to be. You might have to log back off. And what's the last one we did? We did recursion. We are going to rename this guy to be called list of lists, basically. Jack Nichols. I spell Nicholson.
Nichols.
Okay, it looks like it was missing a letter. And it's due today.
I didn't even know.
Do you just want a screenshot or do you want the code?
Just give me a screenshot.
So much easier.
It's just easier to grade. I'm not going to run them. I just want to know that you're doing this stuff. That you're kind of following along. Okay, now I need to unhide it. unhide. All right, you should all be able to see it now. You might have to refresh or log off and log back on. List of lists, because that's kind of a list of a list right here. List of lists, Jack Nicholson, you see it? Should be called List of Lists, Jack Nicholson.
Where did I put that screenshot?
Oh, I should have probably named it as N, but oh well. Doesn't matter.
Jeez, that's it.
All right, and then that's about all we're going to do today. We only got like 9 minutes left. Get your recursion done. I do have some good tutors. Heather works on Tuesdays and Thursdays. Jairus works whenever you let him know.
Where?
In 131.
Okay.
Yeah, Jairus, you email him. His email's right on my door. Jairus White. Anyone worked with Jairus yet? No one in this room? He's the most, he helps more people than ever. Heather only works on Tuesdays and Thursdays, and I know Summer's worked with Heather and Roy. So, okay. So if you got that uploaded, you're done. Get out of here. Oh, yes. Let me copy those down there at this moment, and I'm going to stop this recording.